What's up guys, my name is Dylan and welcome again to another video in my channel. Again, if you're new to the channel, so please subscribe, please leave a like, please hit that bell. I heard it's important that you hit the bell for you to get some notification. And for those who are regular, again, thank you so much for hanging out with me. We are doing a video series and this time we are dealing with OSPF. So in this scenario, let's say you are working for NOC and somebody called in and you need to troubleshoot a network. The problem with this scenario is you only have access to a single router. You do know that they're running OSPF. So before you can further troubleshoot like what's wrong with the network, it would be a good idea to actually have a good picture of what the topology looks like. But you only have access to a single router, and that's the power of using the show IP OSPF database. And with its other features, you can actually map out the topology of an area by just logging into one of the routers in the area. So that's what we're gonna do right now. So let's begin. Okay, so as I was saying, in this scenario, you only have access to router 9. So you logged in and you saw that, okay, I'm logged in to, I'm actually holding to an actual pin. You're logged into router 9. Okay. So the first thing you want to do is you want to suss out like what does this network look like. So just like any good engineer, well, you know, after you've done your show IP interface brief and show IP route, the next thing I would normally run show IP OSPF database, and that's gonna give you like a good view of the OSPF topology. So let's review the LSA types. So the first thing that you will see here would be the LSA type 1s. So here we can actually establish how many routers are in that area. So in this one, we can see 4 routers, namely 150.1.3.3, .6.6, .7.7, and .9.9. So remember, these are router IDs. And where do they get again the router IDs? It can be either hard-coded, it can be the highest IP loopback, or it can be the highest IP configured on the interface. In this scenario, again, the router ID is, it doesn't necessarily mean, it's an arbitrary IP, which means it doesn't have to be an actual IP on your network. It can be as weird as 255.255.255.254. So if we just check on this particular router, show IP interface brief pipe exclude unassign. If we're just gonna look at the IPs on this router, you will notice, as I said earlier, it would normally take, the router ID is normally taken from the highest loopback IP that's assigned on the router. So if that was the case, the router ID would have been this guy right here, 212.18.3.1. Hence, so we can actually track down which router is which. I have hard-coded the router ID as the loopback. Okay. Anyway, going back, so if we go back to show IP OSPF database. So we know that there are 4 routers, and we can see this section right here is the LSA type 2, which is the DR and the BDR. We can see that there are 3 segments on this area. we're in this segment right here. You have, this is the interface IP, and this is the router ID for that segment. You also have like 155.67.6, which is the link IP, and it's coming from this router ID, and so on and so forth. So looking at this one, let's just we've established that we actually have 4 routers, hence we have like 4 circles here representing the routers. So let's say this is router 3, router 6, router 7. Okay. All right. What is the next command that you would usually run? So the next command that I would run is show IP OSPF database for router, and I would ask myself 1.9.9. Okay, so this would tell me a couple of things. One, it's gonna tell me that I am in area 2. This is my router ID, and I am advertising myself with this router ID. I have 3 links, namely this guy right here, which is one of our loopbacks, and it did say that it's a stub network. Please don't the stub network is different from a stub area. Okay, so a stub network in this scenario means that this segment is actually participating or is being advertised in OSPF, but there is no OSPF neighbor in that segment. It wouldn't make sense, right? Because if we check back, and it's also a /32, so that is actually a loopback. And how can you have a peering with anybody on that segment if you're actually the loopback, right? Makes sense. Next, we have this transit network. Transit network is a good thing because it means that it's actually a segment and you actually have a peer there. So here it says that the designated router address is 155.1.79.7. Okay, and the router interface address is 155.1.79.9. So the router interface address, that means that this is our address on that specific segment, which is this guy right here. So we'll mark it here, and that guy is 155.1.79.9, and the designated router address is 155.1.79.7. so somewhere in the network the designated router is 155.1.79.7. If we scroll up, if we look at that, this guy right here, 79.7, the one that's advertising that is 150.1.7.7, which is this guy. Oh, keep on forgetting that. 150.1.7.7, that's the router ID of router 7, and the link is 155.1.79.7. so there's a link between them, and that link is actually, this guy is actually the DR for that segment. Okay, now how do we know it? How do we know, aside from looking at this one, like how many routers are actually participating on that segment? Another way for you to check would be, you can start querying this DR right here. Again, we're not gonna go, we're staying put on router 9, all we have to do is show IP OSPF database for the network, and this is the IP address that we're going to put in here would be the designated router address, which is this guy right here. And it's going to show us this, wherein it's going to tell us that on that link, which is this guy right here, that is the address of the designated router, which is 150.7.7. And on that particular segment, we can actually see that there are just two routers, which is the router IDs are 150.1.7.7 and 9.9. Going back to this one, going back to designated router address, please do not confuse this with the router ID. Some of you might be thinking, remember, if we run the command show IP OSPF neighbor, it will tell us that 150.1.7.7 is the designated router. But how come here it says that the designated router address is 155.1.79.7? This one right here is just telling you the IP address of the interface that's facing you. Because remember, you are router. We are sitting on router 9. Okay, so on that particular segment, it's actually the designated router interface IP, not the router IP or the node IP. Okay. Next, how about, so what's the rest of the network looks like? Okay, so let's go back to show IP OSPF database. So we have solved this part of the network. Now let's see what these two looks like. Okay, so we can start querying from router 9. Let's do show IP OSPF database for, let's stick with router 7. I think router 7 is also the DR on this segment. Oh, show IP database for what was it? Network. Okay. So here on this particular segment, there are actually two routers participating on it, which is 150.7.7 and 150.3.3, which is this router. Ooh. This is 150.1.3.3. Again, this is the router ID. So there's actually just two routers in that particular segment. We can see that the address of the designated router is 37.7. So this guy right here, this is 155.1.37.7. Oh, sorry. Hang on. Oh, I actually queried this guy right here. Sorry about that. So it says that the address of the designated router is 155.1.37.7. Okay, because the advertising router is 150.7.7, which is us. Well, from the perspective of this guy. So how do we know? Like, what's the IP address of this guy? Anybody? Okay, so we can actually ask that router. So if you do show IP OSPF database router, now we put in the router ID, it is going to tell us that I have one link, and the designated router address on that link is 155.1.37.7, which is this guy right here, and the router interface facing that designated router address is this guy right here, 155.1.37.3, which is, so this is going to be 155.1.37.3. Again, there's only one link in area 2. Again, don't forget, we are in area 2. Okay, so let me erase this one. Okay, so we've solved. Remember, let me repeat that, we are still in router 9 and we're actually drawing out the OSPF topology for area 2. So if we go back to show OSPF database, so we've solved this part, which is that guy. We've solved this link right here, which is this guy. How about this link? You can do it a number of ways, so we'll just query the router itself. So show IP OSPF database for router, then the router ID 6.6, and from that guy's perspective, again, he has one link for area 2, and the designated router for that link is 67.6, which happens to be, that's how you know if you actually own or if you are the DR on that link, is because if the designated router address matches the router interface address, which means this node right here, that certain link, that's the DR. Okay, so how do we know? So the 67, so somewhere there is a link to 155.1.67.6. Oh, sorry. Let's erase that. So in this segment right here, so .6 is actually the DR. So how do we know again? How do we find out like how many routers are participating in that particular segment without going to the OSPF? So we go show IP OSPF database, then we'll go to the link itself. So we'll go network, we'll query the link of the DR, and it's going to tell us that, oh look, there's actually 2 routers participating on it, which is router 6, the router ID is 150.1.6.6, and this guy right here. So which makes us believe that this is the link between router 6 and router 7. So now how do we know now that what's the IP address of this guy right here? We can actually ask router 7, right? So if we ask router 7, hey router 7, show IP OSPF database router 150.1.7.7, it's gonna show us that, let me just erase a couple of things here. Erase. Okay, so it's gonna tell us that I have 5 links. Router 7 has 5 links. One is a stub network, which is the loopback, which is this guy right here. That's the loopback. It has a transit I think we've already solved this one, which is this guy, and he is the DR. And we also got this guy right here. Remember, if the designated router address and the router interface address are the same, which means in this on this segment, this guy is the DR. Then this guy right here, another stub network, which means we have another a LAN network probably that's sticking somewhere here. This network is 155.1.7.0. Okay, so that is a stub network, meaning again, as I've said earlier, it is participating in OSPF. It just so happens that there are no other OSPF speakers on that particular segment. Now, going back, my original question is, what is the IP of this guy right here? Now, to answer that, it would be this guy, right? On this network, it says on this certain segment, the router ID or the designated router address is 155.1.67.6, which is this guy. And the router interface that's on my router, on router 7's interface, that is 67.7. So that router there is 155. I'm sorry guys if my handwriting is not that perfect. 67.7. And there you go. I believe we've already built the topology, the OSPF topology for area 2 without actually jumping on to the rest of the network. So remember, the way we did this is we just logged in to router 9. You have to remember as well that since OSPF is a link state distance vector, no, not a distance vector, it's a link state protocol, link state router protocol, and it has each router on the area has a copy of the topology, so everybody knows all the paths. So basically, if you can just, all you need to do is just log on to a single router, in this case router 9. You can start asking all the routers within your area what the topology looks like from their end. So again, OSPF or rather show IP OSPF database and all of its other options is they are a very powerful tool, especially in troubleshooting, in order for you to have an idea what the OSPF topology looks like. Now you might be asking, hey, this is area 2. How about area 0? Isn't this thing supposed to connect to area 0? Yes. That's why if we go back to OSPF show IP OSPF database, we haven't discussed this one, the LSA type 3, which are the ASBR or the area border router. In this scenario, in area 2, we have 2 of them, which is 150.1.3.3, which is this guy right here, and 150.6.6. So I'm not going to discuss that in this video, and I will start doing that in the next video as we try to weave our way through the network. Okay, so another command that will be useful would be show IP OSPF border routers, and that's gonna also tell you like what are the border routers in my area. So from router 9's perspective, I can see 2 border routers, which is 6.6 and 3.3, which means they are participating in like some other area, whatever that is. It can be router 0, it can be like router something, we don't know. And the only way for us to know would be to log into that router and continue on trying to map out, running our show commands in order to figure out what the topology looks like for this particular network. I'm gonna stop right there. I hope you learned something useful, helpful for maybe at work, maybe for your certification journey, regardless if you're studying for the CCNA, CCNP, CCIE, routing and switching. Thank you so much for hanging out with me. It's been 25 minutes. Just to give you a trivia, this is actually my second time of recording this one. The first one was actually running for 30 minutes. I don't know why. Then after all that recording, I found out that it wasn't recording. The mic wasn't working, so I had to redo the entire thing again. But anyway, I hope this has been informative to you guys, and thank you for viewing. And always remember that keep on studying. Believe me, it's so worth it. Thank you so much, and you guys have a good day.